guys, this is Steve with Classic Cars Driven by Data. In this week's episode, we're going to take a good look at the basics of the H-type SU Carburetor. In this car, you can see there's twin SU carbs, H series or H-type, and they're 1.5" diameter throat. So that makes them H4. You can see in this graphic, this vehicle is also fitted with a cool air intake. If you're interested in why it's got a cool air intake and why it's useful, then look for that episode. You can subscribe and then you'll find it easier to locate, or you can just search on MGA cool air intake and you should find that episode. Here you see the intake manifold. The two carbs are bolted via a flange at this point here to the intake manifold. This is the throttle body, more or less, between the intake manifold and the main body or the piston unit, I should say, of the carb. And we're going to show you the details of that shortly. Here's the fuel supply, which feeds each of the carbs in turn into their respective float chambers. And over here you can see an inline filter where we try to keep rocks out of the carburetors and keep everything clean and working properly. So credit to Moss Motors for this graphic, but it really does show what we're dealing with here with this MGA. So these are H4 carbs, and you can see all the things I've just talked about. You can see the piston units here. This is the dashpot fill, so that you need to keep some oil in the dashpot so that you've got some viscous damping of this piston. It doesn't leap up and down when you hit the accelerator. Here's the fuel supply, and here's the float chamber. This rod here is in fact connected to the butterflies in each carburetor, and these two are ganged together. There's a coupling that connects these two rods together so that one accelerator cable connected to the pedal on your right foot can be used to open both butterflies. What else can we see? Well, there's the fuel jet here. When this is lowered, you're going to get more fuel or richer mixture, and when it's raised you should get less fuel, courtesy of the tapered needle that's attached to the bottom of this piston right about in this position here. And this is the linkage that's used for cold start, basically a choke linkage. So there's a choke cable that pulls on these two linkages and raises them up. This is the pivot point here, and so when this end is raised, then this will pull down. It'll open up the jet on the taper of the needle, so to speak, and the net area of the fuel jet will increase and you get more fuel flow. So basically it's a way to get some temporary enrichment, and that's the whole purpose of this rather complicated linkage underneath here. So this is how it operates. So you see there's a little bit of lag between the butterflies. So you can imagine standing on the accelerator pedal, opening the butterfly via the control rod that I just showed you. That increases the airflow. The additional airflow through the Venturi causes a pressure drop or an incremental pressure drop. That pressure is communicated through this drilling here to the top side of the piston, and simultaneously the underside of the piston via this drilling is exposed to more or less atmospheric conditions. So when the butterfly is opened, the pressure will drop above the piston. It'll raise the piston. And the beauty of this design is that the tapered needle combined with the piston being raised works in concert with the airflow to maintain a more or less constant air-fuel ratio. Very clever device. Down here you'll see the fuel jet shown symbolically, fuel supply into the jet area, and then you see the fuel flowing out of the jet, mixing with the air over the throttle and then into the engine. So the butterfly is connected directly to the accelerator pedal. The underside of the piston is connected to atmospheric pressure by drilling at the inlet flange which we'll talk about later. The top side of the piston, as I've said, is connected to the Venturi. The Venturi is this restriction here in the airflow. So the airflow path here is unobstructed, about 1.5 inches diameter. But then when it gets to this point, you can see it's restricted by features in the casting here, but also by the position of the piston. And so the pressure in here is going to be lower than the pressure upstream, and that pressure difference is what drives this piston up and down depending on conditions. As the piston moves up, the taper of the needle increases the effective size of the jet and increases the amount of fuel flowing to match the increased airflow. Here's the dashpot. I haven't tried driving without any fuel in the dashpot, but I'm pretty confident that if I did, I would get kind of a kangaroo activity. That I think the car would lurch forward and then it would slow down again, then lurch forward. And that would be due to the undamped oscillation of this piston here. If you stamp the throttle, or even were fairly aggressive with the throttle, this is going to go flying up and then it's going to come down again and basically be undamped. So be important to pay attention to the fluid that's in here and to make sure, one, that there's plenty of fluid, and two, that you don't use an oil that's either too thin or too thick. If it's too thin, you might get into oscillations and unsteady lurching of the car as you drive it. If it's too thick, you might get a very doggy response. As you nail the throttle, it's going to take time for this to rise and for the oil to pass around this obstruction here, basically the dashpot device. So you may want to be careful with that. I believe SAE 20 oil is the recommended, so you might want to bear that in mind. There's an adjusting screw so that if you need to adjust the mixture, which I would suggest you be very careful with, then a downward movement of that screw and jet increases the fuel flow, makes the mixture richer, and if you move it upwards, that makes for a leaner mixture. So here we are, we're removing the piston unit to expose the piston. So there are just 3 screws, and it's important if you do, especially if you've got twin carbs, don't get them mixed up. Don't get the wrong piston in the piston body. Don't get them crossed over. Keep them separate and keep them matched up as a pair. This piston here, which we're going to see removed in a minute, it rides in the body of the piston unit here, and it's it's just a nice smooth fit. If it leaks too much, you're going to be in trouble, because remember, you've got a pressure difference between the underside and the top side, and that's basically what's controlling the whole carburetor, the air-fuel ratio control. So it's pretty important. Now I've removed the piston unit completely, but left the piston in place. So this is the piston here. This is attached to the piston. The damper is inside here. And what else can I say? Well, here's the cool air intake. Oh, it's a nice shot of the throttle control rod. The butterflies are right here, and it's controlled by the rotation of that rod. Once again, fuel inlet and the fuel float chamber. So this is a look at the piston. This is the top side of the piston. And you see these 2 drillings, they communicate with the Venturi, or the restriction caused by the body of the carburetor and the underside of the piston. So you can see that they are drilled all the way through, such that the top side of the piston is then exposed to that Venturi pressure, which raises it under certain circumstances and allows it to fall under other circumstances. This is the carb body, so to speak. You can see the fuel jet down at the bottom there, just about. Not all that clearly, but you can see it a little bit. These holes here, these 2, they communicate through drillings into the, in this case, the cool air intake. And that allows the communication of something very close to atmospheric pressure to the underside of the piston. So the piston rides in this bore, but its outer diameter is right out here. So that these two communicate with the underside of the piston and allow atmospheric pressure to be there to raise the piston as needed. So this is illustrative of the kind of drilling. It goes through the body of the carb, through the flange, through the gasket, and on into, in my case, into the cool air intake. So here's another shot. This just shows the throttle cable, and it shows, in fact, that screw that's circled is in fact the idle adjustment screw. And when you're tuning these two carbs, one thing you're going to want to do is measure the airflow through each carb at idle, and then adjust those screws so that you've both got a nice idle speed, say 600-700 RPM, and that they're both balanced, that the butterflies are in exactly the right spot, and both carbs are doing the same thing in terms of airflow. So this, once again, this is the throttle cable, and here you see the crank mechanism by which the throttle cable operates the butterfly. So this is the rod that runs through the butterflies. There's the crank. There's the cable. So when you push the accelerator pedal, you're going to lift this crank arm, rotate the butterfly rod, and then open the butterflies to let more fuel into the engine. This view shows a number of different things. Let's see, what have we got? Well, that's the cam that is used to increase the idle speed when the choke is operated. So there's a linkage right about here that goes down. You can barely see it, but it goes down to the linkage arms underneath the carburetors. And so when the choke cable is pulled, then this cam gets rotated via that rod, which raises this arm, and you can see it's actually attached to, via a crank, to the butterfly control rod. So you're going to raise the idle speed under choke conditions. And over here you've got yet another view of the accelerator cable and the crank through which it operates the butterfly rod. Here's where the fuel enters the float chamber. There's the float chamber. This overflow is kind of interesting. If there's some malfunction of the float chamber, such as the float being punctured and filling with fuel, or the valve mechanism getting stuck, then any excess fuel is going to flow out of this pipe onto your garage floor or wherever you happen to be. So that's not a good situation. So if you smell fuel and you're wondering what it is, this might be the first place to look. Here's another view underneath, which shows some nice detail. This little pipe is in fact the vacuum advance for the distributor. So this will communicate the vacuum that's in the intake system to the distributor. There's a diaphragm on the side of the distributor we'll look at in a second, and that advances the timing under conditions of either light load or idling, when there is in fact a vacuum, and it can advance spark timing by about 10 to 15 degrees. It's pretty significant. Again, that's something to keep an eye on. Make sure it isn't clogged, that the vacuum is being transmitted successfully to the distributor. If it isn't, you're going to have some issues. So this is where the fuel comes into the main body of the carb from the float chamber. It's a little bit like a banjo fitting, but the whole float chamber just hangs on that connection as well. That's how it's assembled. And this is the jet adjustment mechanism. So you've got a hexagon head here if you want to make permanent adjustments to the mixture strength, as we've said earlier, if you lower it, you're going to enrich, and if you raise it, you're going to lean off the mixture. But also during cold operation or cold start operation, as we've said several times, this cable here will lift the two levers, this lever and that lever, and then about this pivot point here, you'll get rotation of the linkage, and it will pull the fuel jet down temporarily to allow rich operation under cold conditions. So a pretty ingenious mechanism. Ultimately, there's not such a lot to it, but it's worth thinking about and getting to know how it works. So this is the distributor, and you see the diaphragm, or you don't see the diaphragm, but this is the housing for the diaphragm. It's operated by vacuum at this point here, and it operates to rotate the distributor mechanism to advance the timing under light load conditions. This is another view underneath the carbs. There's the pivot point, the fixed linkage that acts as a pivot. So the lever will rotate about this point here. There's the jet, which, as we've said several times now, when the choke cable is pulled, it raises this side of the lever, but lowers this side of the lever, and allows more fuel into the engine temporarily under cold start conditions. And this is where the float chamber is attached to the main body of the carb. So here's the float chamber over here. And this is just a cantilever arm that allows fuel to flow from the float chamber into this area here. And from there it flows into the jet area and then upwards into the body of the carburetor. So there you are. These are the basics of the SU carb. I hope this has been useful to you. There's the butterfly that controls power. The underside of the piston is connected to the atmosphere through the flange where the filter connects, or where the cool air intake connects to the carburetor. The upper side of the piston is connected to the Venturi. This is where the pressure is reduced because it has to accelerate to get through the Venturi. Hence the pressure drops, and then that drop in pressure is what raises the piston against atmospheric pressure. When the piston moves up, the tapered needle moves up, and you can see that the net area at the fuel jet inside the red circle is increased because the needle is getting smaller because it's tapered. That lets more fuel into the carburetor. And the whole goal of this carb is to keep the airflow and the fuel flow in direct proportion to each other, typically between 13 parts of air, 1 part of fuel, to 14.7 parts of air, 1 part of fuel on a mass basis. So what else? So there's the dashpot. I said earlier that this is important, not to be ignored. If you're racing, you need to pay a lot of attention to it because you want a fast response, but at the same time you won't want an unsteady response. And if you're not, if you're just using the vehicle on normal roads, you want to pay attention to it. You don't want the oil to be too thin and have herky-jerky response of the vehicle, and you don't want it to be too thick because then you won't get any reasonable throttle response. It's going to take time for the piston to push that oil through the dashpot because of its viscosity. So bear in mind that the recommended oil is SAE 20. There's an adjusting screw at the bottom of the carb on H model SU carbs. Moves the jet vertically to tune the mixture. Down is richer and up is leaner. So that concludes this fairly quick look at the H-type SU carburetor. I hope you found it interesting and enjoyable. If you'd like to see more, episodes along these lines, then hit the subscribe button and the like buttons below. Thank you.